आफ्टर टायरिंग डे ऑफ स्टडीज आपने डिसाइड किया है टू वॉच अ मूवी एंड हैव सम पॉपकॉर्न्स। सो आप क्या करोगे? आप जाते हो किचन में, उठाते हो प्रेशर कुकर और आप लेते हो कुछ कॉर्न्स। आपको पता है कि कॉर्न के अंदर का एयर का वॉल्यूम डबल होगा तो वो पॉप करेगा और बनेगा पॉपकॉर्न। इनिशियल टेम्परेचर प्रेशर कुकर के अंदर जो है दैट इज रूम टेम्परेचर 25 डिग्री सेल्सियस। तो आप उस कुकर के अंदर का टेम्परेचर कितना तक बढ़ा दो ताकि आपका जो कॉर्न है वो पॉपकॉर्न बन जाए। अगर आपको जानना है इस सवाल का जवाब तो ये वीडियो है आपके लिए। हेलो एंड वेलकम टू दिस ब्रांड न्यू वीडियो ऑफ बडिंग मरीनर्स। आई एम प्रियांशु कुमार गिरी, योर फिजिक्स एंड केमिस्ट्री mentor on this channel. I am currently pursuing a bachelor's from IIT Madras and this video is going to be on Charles law. So before I begin the video, like, share and subscribe. And do not forget, fill the Google form in the description for more assistance from budding mariners. So let's begin with understanding what Charles law is. So this law states that at constant pressure, the volume of an ideal gas is directly proportional to its absolute temperature, which means that at constant pressure, V is directly proportional to T. This is what the Charles law says. We will see an experiment now to understand it better. So the experiment is at constant temperature P, let's take a container of gas with volume V and temperature T. If I increase the temperature, then what will happen is the molecules of gas will have more energy and thus they will try to increase the intermolecular gaps. Okay, and with the increase in the intermolecular gaps, the volume will increase because the gas will expand. So increase in temperature results in increase in volume, and thus we can say that V is directly proportional to T. Now if we remove the proportionality, equals to will come and a constant K will come. We can solve it further to get V by T equals to constant. Now what does this mean now? So this means that for an ideal gas at constant pressure, the ratio of volume and temperature is always constant. Okay? Now let's say in an experiment at point 1, we have a point 1 in an experiment where the volume is V1 and temperature is T1. In the same experiment, we have another point 2 where volume is V2 and temperature is T2. Then what will be the relation between all these parameters? The relation will be V1 upon T1 is equals to V2 upon T2. Okay, this will be the relation. Now if suppose we have more than 2 points, let's say more than 2 points we have, then in that case this can be extended further. V1 upon T1 is equals to V2 upon T2 is equals to V3 upon T3 and so on and so forth. All of them will be equal and they will also be equal to a constant value. Okay, this is a important result. Please note it down. So now, since we know that V is directly proportional to T, this implies that V is equals to KT. Now, if we plot a VT graph under constant pressure, that graph will be the graph of Charles law, which will look like this: a straight line passing through the origin. Okay, if the angle of inclination of this line is theta, then the slope of this line will be equal to tan theta, which will be equal to the constant K. Simple. Now let's do this experiment 3 times. First under pressure P1, then under pressure P2, and then under pressure P3. Constant pressure, but the experiment is done thrice. Okay, where P1 is greater than P2 is greater than P3. Okay, and then we plot the graphs. Okay, so P1 first graph, then P2, and then P3. So more the pressure, more the line is towards the t-axis. This way you can remember that how will the VT graph look under different pressures. Okay, so you must note this. So let's now solve our first question on Charles law. The question is, at constant pressure, the volume of an ideal gas increases from 2.5 liters to 3.75 liters due to increase in temperature. If the initial temperature is 27 degrees Celsius, calculate the final temperature in degrees Celsius. Let's solve this. So here the initial volume V1 is 2.5 liters. Initial temperature is 27 degrees Celsius. Let's convert it to Kelvin because Kelvin is the SI unit. So for converting Celsius to Kelvin, we add 273 to the Celsius value. We get the Kelvin value to be 300 K. Now V2 is 3.75 liters and T2 is unknown. Now let's apply the Charles law, that is V1 upon T1 is equals to V2 upon T2. Putting in the values, we get this 2.5 upon 300 is equals to 3.75 upon T2. Solving for T2, we get this, and solving it further, we have 450K. Okay, but the answer is asked in Celsius. So for converting Kelvin to Celsius, we subtract 273. So by subtracting, we get 177 degrees Celsius, and this will be the final temperature of the gas. So now let's solve the question that we discussed in the beginning of this video. You want to cook some popcorn to enjoy it along with your movie. The volume of air inside the corn must at least be doubled, so the corn pops to form popcorn. Okay? Now, if the initial temperature inside the pressure cooker is 25 degrees Celsius, then what should be the final temperature inside the pressure cooker for the popcorn to be ready? In degrees Celsius. Assume air inside the corn to be an ideal gas. Okay? Now, let's solve this. So here T1 is equals to 25 degrees Celsius, which is 298 Kelvin. You just add 273 to 25, you get 298 Kelvin. Now T2 is unknown, T2 is needed to be found. Let the initial volume of air inside the uncooked corn be X. ठीक है, क्वेश्चन में क्या बोल रखा है आपको कि डबल होना चाहिए जब वो कुक होगा तो इन दैट केस V2 विल बी 2x. ठीक है, डबल हो गया वो. नाउ लेट्स अप्लाई द चार्ल्स लॉ. V1 अपॉन T1 इज इक्वल टू V2 अपॉन T2. ठीक है, सो लेट्स पुट द वैल्यूज. ये वैल्यू रहा आपके पास. Now let's cross multiply and solve. So T2 will be equal to 2 times of 298, which will be 596 Kelvin. अब आंसर आपसे पूछा है सेल्सियस में. Let's convert to Celsius. We subtract 273 from the Kelvin value to get the Celsius value. कितना आया आंसर आपका? 323 Celsius will be your final temperature of the pressure cooker. Now, hence the temperature inside the pressure cooker must be raised to 323 degrees Celsius for your popcorns to be ready. So guys, this was all about Charles' law. I hope you liked the video. If you did, then like the video, share with your friends, subscribe, press the bell notification, and comment down below your thoughts. Also, do not forget to fill the Google form in the description for more assistance from budding mariners. See you in the next one.
Do you guys want the updates regarding the exam forms or the maritime industry in general? या फिर एग्जाम्स के लिए मोटिवेशन चाहिए, then you definitely need to follow our Instagram channel for all this stuff and much more.
Want the best notes and material for Imucet and sponsorship exams? Want daily quizzes? Or do you want your doubts about your merchant navy career solved by our mentors? Search Budding Mariners on Telegram or click on the link in the description below to start your mariner journey with us today.